Aloha, my name is Pelayo, and for my PEEC2 project, I created a battery-operated hunting feeder to assist with the population control of feral pigs in Hawaii. Traditionally, Native Hawaiians were a very sustainable and ecologically minded people. Everything was used fully with the ahupua'a system, kalo, and sustainable farming practices. And with the transition to plantations and larger scale farming, that has been lost. And now with the explosion of feral pigs on the island of Oahu, now more than ever, we need to look towards our own island as a source of food. Also, feral pigs, in order to maintain their population levels, you need to eradicate at least 70% of them each year for the population to remain the same. So the goal of this project is to create a hunting feeder to assist with the eradication of these pigs and to make that a possibility for anyone, whether they live on the top of a mountain or in a valley. To begin the project, I started with very little knowledge of Arduinos or any sort of coding or electrical work in that sense, so I did a lot of research on the Arduino Uno and the possibilities with the many different sensors that we were given of what was available for us to use. Originally, I started out with identifying the real-time clock sensor, or RTC sensor, and connecting that to the Arduino and coding it to be able to keep time. The RTC sensor has the ability to keep time even with a loss of power from a battery source. So once I got that coded and it was able to continuously display times even once we removed it from the power source, the next step was figuring out how I was going to integrate that timekeeping function into the feeder. After looking through the sensors again, I landed on the relay switch that would open and close the electrical flow for a motor that would operate the feeding mechanism. So next came connecting the relay switch to the Arduino. Because the Arduino only has so many ports, that I had to integrate the breadboard into the use of the Arduino. So after connecting the RTC through the breadboard, I connected the relay switch to the breadboard as well. After the relay switch was connected and I had everything wired, I found some different codes online for people who had made alarm clocks. So I tweaked their code to have the relay switch essentially open and close at a designated time. And once I had that figured out, I added in essentially another loop in the code to have it open and close at another time throughout the day. And once that was all set, I ran a trial on that for about a week, and while I worked on the other parts of the project, and observed it continuously working and opening at either 5:30 a.m. or at 7 p.m. After I finished the coding and electrical component side of the project, came the feeding apparatus itself. I landed on using a two-tube system, similar to that of a toothpick dispenser. I looked at all different types of feeding mechanisms, from kind of paddle wheel systems to cereal dispensers. And I landed on the two-tube system because of the lack of friction and extra energy needed to push against the grain that would be stored in the upper part of the contraption. If you had a trapdoor, you would have to have the power to close the trapdoor against the 15 pounds of feed that are going to be stored in the box. So by having a rotating tube, you eliminate that. And in these figures, these are the front and side views of the orthographic drawings of the inner tube and the outer tube. And on the right, you can see that the motor will sit in between the sidewall and the outer tube and be connected to the center of the inner tube. And after I figured out what feeding mechanism I wanted to do, I drew up these plans and more of the volume that the feed would take and the other components that were going to go into making the full feeder. So these are the results. On the left figure there, I have the inner and outer feeding tubes. There was a hiccup with the outer tube. PVC has to either be specially ordered or you can't get it in the right stepped increments. So for my inner tube, I went with a 3-inch diameter, and there's no PVC stepped in an increment that would allow me to have the inner tube sit flushly with the outer tube. So I resorted to making my own outer tube out of plywood, which required me to make a bunch of kerf cuts on a piece of plywood and then essentially bend the plywood into a tube. So that wood tube was originally a flat piece of plywood. And then I had to cut the channels into the outer tube and the inner tube and let the outer tube dry once it was glued in place. And then after that, put it all together in the larger box. On the figure on the right, you can see the space through the crack in the top where the corn feed will be held. And I obviously glued those walls together and sealed up the feeder. And this figure at the top is the waterproof housing that held all of the Arduino components that I had drilled to the side of the feeder box. In conclusion, this battery-operated hunting feeder was a success in its design. I still have to finish connecting some of the components. I'm waiting to get a solder to finish soldering 2 wires that will essentially connect the motor to the Arduino successfully, and then from there can begin running tests in the real world. There are a few things I could change. I could integrate solar panels as well, so that you wouldn't need to come out and change the battery on the Arduino. I could also incorporate battery saving code on the Arduino, or even build my own Arduino. I looked into a lot of battery saving options for Arduinos, and a lot of the recommendations were building your own Arduino. I could also change the design of the feeder lid and put a slant on it to help water run off of it better. Another area that I can improve would be the outer tube of the feeding mechanism. Although it is a success right now and it's working, and the inner tube is able to rotate cleanly, having a either 3D printed or proper size PVC would just make it that much smoother. And these are my references and acknowledgements. Thank you so much to Aaron and Jacob and all the peer mentors that helped throughout this entire process. Thank you for your time.